Yes, completed this one.
Yes sir.
एक और अभी देता हूँ, फिर इसका यूज वर्क डन में कैसे होगा वो देखेंगे हम लोग. If f is 3y I cap plus 3x j cap, check whether conservative or not. Here x component of force is 3y and y component is 3x. Z is 0. So derivative of x with respect to y will be, this is now 3y. 3y ka derivative with respect to y is 3. And y with respect to x, 3x with respect to x is 3. So y, x ka derivative with respect to y and y ka derivative with respect to x are same. Both are 3, 3. Now y with respect to z will become 3x with respect to 0 means 0. And z with respect to y will also be 0. That means both are equal. Third one, x with respect to z will be 0 and z with respect to x is 0. So all the three are same. Therefore, force is conservative. Okay.
Yes, sir.
Yes, sir.
Try this also.
Done, sir.
Next one, you try on your own. If f equals to f equals to 3y I cap plus 4x j cap. 3y I cap plus 4x j cap. Check whether conservative or not conservative. Check whether conservative or not conservative.
Non-conservative.
Correct. One you are getting 3 and other you are getting 4. Na?
Yes.
So not conservative. Now using this concept, see, we have to do work. F equal to I cap plus 3y j cap acts on a body as shown. Calculate the net work done. O to A to B to C, it comes back to O. Coordinates are 0, 0, A comma 0, A, 0 comma A. Calculate the work done. If body goes from O to A to B, B to C, back to O. Options are 3A, minus 3A, 0, and 1 upon 3A. See, first of all, is it closed loop? Started from O and ending at O. That means it is closed loop.
Yes, sir.
Now Now, if this force becomes conservative, then for closed loop, what will be work?
0.
0.
So my only job is what? Check whether it is conservative or not. अगर conservative है तो 0 हो गया. Idea आया?
हाँ
Here what is fx? 1 na? And fy is 3y. So derivative of x with respect to y is how much? Derivative of x with respect to y 0. Derivative of y with respect to x, तो ये 3y उसके लिए 0 है. Then derivative of y with respect to z, y with respect to z 0, z with respect to y 0, x with respect to z also 0, and z with respect to x also 0. तो क्या मिल गया? Force is conservative, work done is 0. Clear na?
Yes, sir.
Solve. So if paper is difficult, then this type of things will come. Whatever is given in NCERT, I am doing all.
Done, sir.
If f is x square I plus yj acts on a body and it is taken from A to B as shown, which is correct. So it is taken from A to B, this path, and A to B along second path. Then is work done in first same as second? Work done first is not equal to work done in second. Work done in first is greater than that of second. Third, work done second is greater than work done first. Now, if it is conservative, then work done is same because it is independent of path. So F equal to x square I plus yj cap. X component is x square and y component is y. So derivative of x with respect to y is 0 and derivative of y with respect to x is also 0. Derivative of x with respect to z equals to 0 because z component is 0. Z with respect to x also 0. Now y with respect to z will be 0 and z with respect to y is 0. So all are equal. Therefore force is conservative. Therefore work done in first case and second case same answer first. Write it.
Yes, sir.
Now related to kinetic energy, potential energy and power will do, and then energy, so that work or energy ka synopsis also we can complete. This kinetic energy, thus this kinetic energy depends upon frame of reference or not? Theoretical question agar pucha to. See, whenever you say any formula of kinematics, it is with respect to inertial frame. That means somebody is standing outside on earth and then the body is moving. Now imagine this is one vehicle moving with velocity v, and a person is observing from outside on earth. What will be kinetic energy according to this person? A half mv square.
Yes, sir.
But same person sits inside this. A sits inside. Now what is kinetic energy of vehicle with respect to A?
0, sir.
0.
Zero, because
Zero.
उसके लिए relative velocity zero हो गया. So we can say kinetic energy depends upon frame of reference. तो ऐसा छोटा छोटा theoretical sometimes they can ask. So all kinematic equation, all motion depends upon frame of reference. Just write down a short lines.
Done, sir.
Okay. What is work energy theorem? It is work done by all the forces. It can be conservative force, it can be non-conservative force, it can be internal force, it can be external force. Work done by all the forces on the body is always equal to change in kinetic energy of the body. Work done by all the forces on the body is always equal to change in kinetic energy. If work done is positive, then kinetic energy increases. If work done is negative, then kinetic energy decreases. That means I can say work done by all the forces means conservative, non-conservative, internal, external, or any force. Always it is nothing but change in kinetic energy. Right now. To be more precise, it is final kinetic minus initial kinetic. This Sunday you all will have test on law of motion. Ananya, please you also write, huh, if you get time.
Yes, sir.
Just whenever you get time, please write it.
Yes, sir, I'll do it.
So that you get idea ना कि ये भी आ रहा है क्या?
Yes, sir. Yes, sir.
हाँ हाँ.
Done, sir.
So I got now two formula of work done. Either I can say F bar dot S bar, or I can say work done is change in kinetic energy. So you have to keep this two in your mind. I'm solving few questions based on this to get idea how the change in work, change in kinetic energy is worked. So first few theoretical type I'm doing, then we'll come to MCQ from that booklet. A body of mass 2 kg is acted upon by force such that velocity time graph is as shown. Find work done by this force. So this is velocity time graph. This is 10. This is 2 seconds. We have to find what is work done. Nowhere you can see force and displacement. So I cannot solve by this method. But definitely I can solve by this method. What is initial velocity when time is 0? Initial velocity 10 or not?
Yes, sir.
And when time is 2 seconds, what is final velocity?
0.
0. So I can say work done equals to change in kinetic energy. So it will be half m final velocity square minus initial velocity square. Half mass is 2, final velocity is 0, minus 10 square. 2 cancel. Minus 100 joule will be the work done. So from graph we can find work done by using work done is also change in kinetic energy. Any doubt in the sum?
No, sir.
Solve.
Done, sir.
Okay. Next one. A body of mass 1 kg is acted by some force. A body of mass 1 kg is acted upon by some forces such that its displacement is given by S equals to 2t square minus 2t plus 10. 2t plus 10, find work. by all forces in 0 to 2 seconds. By all forces in 0 to 2 seconds. See, because displacement is given, but force is missing. So again, I can use the concept of work done is change in kinetic energy, which is final minus initial kinetic energy. That means half m v final square minus half m v initial square. Derivative of displacement, we know it is velocity. So when I put 0, I get initial velocity. When I get 2, I put 2, then I get final. So S is 2t square minus 2t plus 10. Rate of change of displacement is 4t minus 2. So when t is 0, initial velocity will become 4 into 0 minus 2, which is minus 2. Similarly, final you can find, then substitute in this formula. Can you try on your own further?
Yes, sir.
Do it.
Yes, sir.
ये थोड़ा मैथ्स वाला बेस चैप्टर है. डिस्प्लेसमेंट का डेरिवेटिव इज कॉल्ड वेलोसिटी.
सर एफ डॉट डी एस से भी कर सकते हैं आप.
एफ दिया नहीं ना बेटा, एफ है नहीं.
सर एक्सेलरेशन निकाल सकते हैं ना एस से.
तो वापस 2 बार करना पड़ेगा ना आपको डेरिवेटिव, इसलिए ये मेथड ज्यादा अच्छा है.
ठीक है.
उससे भी कर सकते हैं, सब ले दे के एक ही है ना. But only the thing here, directly you will get velocities. Here then 2 times you have to differentiate, then find angle between them, and it is not in vector form. See, this is not in vector form, no? So we don't know about force ka direction.
Okay, sir.
Sir, 16 joule.
16 joule is correct answer. All of you got same 16 joule? Check कर लो एक बार.
Yes, sir.
A body is acted upon by a force such that its displacement x is related with time as t equals to root of x plus 3. Find work done by this force in 0 to 6 seconds. Work done by this force in 0 to 6 seconds. Now see, this is not in proper simplified form. I am simplifying it. Root x plus 3. So from this root x will become t minus 3. When I square it, root x square is x, t minus 3 square. So x will become t square minus 6t plus 9. Now this becomes similar to our previous sum. dx by dt is 2t minus 6. Hello?
Yes, sir.
Now after this you can do put t is 0, you get initial velocity, 6 you get final velocity, then work done is half m v final minus v initial squares. Can you do this now further?
Yes, sir.
Just try.
Yes.
Try. Yeah.
Sir, is it 0?
Yes, answer is 0. Correct. 0 is the answer. Correct one. Just check. Others are also getting 0.
Yes, sir.
Okay. 0 is correct answer. Next one, see. A body of mass m equals to 2 kg is acted upon by some forces such that V equals to alpha root x. Find work done by all forces from x equal to 0 to x equals to b. Now v is alpha root x. X0 means initial velocity is alpha root 0, which will become 0. V final will be alpha root b. So now work done is half of mass 2 into V final square. That means it will be alpha square V minus 0. 2 cancel. Work done is alpha square. Right, next sum.
Done, sir.
Okay.
Sir, 2 minutes.
Sir, 1 second.
Yes, yes, yes.
Done, sir.
अलग टाइप का क्वेश्चन थोड़ा. A body of mass m is tied to the string. It is taken to the position making angle theta with the help of force F, which is variable. So a variable force displaces M gradually and slowly, then work done by this force, work done by this force is, first option is given, M G L cos theta, second M G L cos theta minus 1, third is MGL sin theta, and fourth is MGL into 1 minus cos theta. Find work done by this force. See, there are three forces here. One is mg डाउनवर्ड एंड टेंशन T, और एक F जो ग्रेजुअली इसको ऊपर लेके जा रहा है. This is length of string L given. Hello?
Sir, D.
mg L into 1 minus cos theta.
Yes, sir.
Why it is like that?
Sir, energy conservation use किया है इसमें, MGL minus MGL cos theta.
That means
Initial minus.
वो तो डायरेक्ट आ गया बिकॉज टेंशन इज एक्टिंग परपेंडिकुलर टू द डिस्प्लेसमेंट ना, तो उसका वर्क जीरो हो गया. इफ आई यूज माय आंसर इज करेक्ट. बाय लॉ ऑफ कंजर्वेशन ऑफ एनर्जी H becomes L into 1 minus cos theta. Kinetic potential becomes kinetic, kinetic becomes potential because that force F is taking it up. So just write, then I'm giving you three explanations. How else we can find? Your method is perfectly right.
Done, sir.
Okay. So we want total W by all these forces, work done by all these forces. Three forces are there. सबसे पहला, since body is raised gradually, if gradually means speed does not changes, it is maintained constant, उसको बोलते हैं gradually change किया. So initial kinetic is final kinetic. Work done by all forces is change in kinetic energy, which is zero we are getting. So work done will be by mg, work done will be by tension, work done will be by force is zero. So conceptually, three forces are there. I want work done by all these forces. So work done by all the forces is zero. So work done by F is my requirement. Work done by F. इधर तक समझ गया आपको?
Yes, sir.
Now H means L into 1 minus cos 3 Rn, cos theta Rn set correctly. So work done by gravitational force mg will be equals to mgh. That will be minus mg L into 1 minus cos theta, gravitational force. Tension is along the string and displacement is along the circumference. So tension and displacement are perpendicular. Work done by tension is zero. So work done by gravity plus work done by tension plus work done by force is zero. That means we work done by gravity plus zero plus work done by force is zero. So work done by force becomes minus of work done by gravity. Therefore, it is equals to mg L into 1 minus cos theta, which is minus ka minus plus. So this is right approach. Work done is total force 3, लेकिन answer same आया because tension was perpendicular and the other two will be opposite to each other. So actually this is the method to solve if they give 3 force.
Sir, H कैसे आया? I did not understand.
आपने सर्कुलर मोशन पढ़ा है ना, मैंने आपको, आपने एक डाउट भी पूछा था सेम नंबर 61 लॉ ऑफ मोशन में, अगर याद रहेगा तो।
हाँ
याद है 1 प्लस कॉस थीटा स्क्वायर था।
हाँ
तो ये देख लो, अब ये स्टैंडर्ड है, जब भी थ्रेड रहेगा ना, थ्रेड, हेलो हेलो,
yes sir.
whenever it is problem of body tied to a thread taken up to certain height, this is ground, ये L है टोटल, इधर से इधर, take it up to certain point which is at height h above the ground, so this part will become L cos theta, this one, if this is theta,
Yes.
so total L minus L cos theta is h.
Okay, got it.
ये पूरा होने के बाद फिर से बताता हूँ, नहीं समझ रहा है तो जस्ट कॉपी दिस, फिर एक बार समझो, बिकॉज जब भी थ्रेड वाला प्रॉब्लम आया और एंगल थीटा आया ना, तो यू हैव टू नाउ कीप इन माइंड L into 1 minus cos theta is h. So sometimes they will give interval, दो एंगल देंगे, theta 1 theta 2, so difference in height also you should know how to find. Hello, yeah, see, fees is 30,000 and timing is, see, right now tentative timing we are keeping for 2 weeks, and then we will frame with respect to all other teachers so that it doesn't clashes with any of the timetable. I will send. Today lecture is, today you have lecture 5 to 6. And measurement. I will join you in that group and I will send you the link just 10-15 minutes before the lecture. Okay. Yeah. Thank you. Thanks a lot.
Done sir.
एक बार ना फिर मैं आपको एच समझा देता हूँ बस अच्छे से डायग्राम बना के. This is thread. At the free end, mass is tied. So this entire distance is length of string. This much, so I think you follow.
Yes sir.
When it is taken up to height h from the bottom, such that string makes angle theta at that position. So this is length of string. Theta ka baju wala is cosine.
Yes sir.
So can I say this height h is L minus L cos theta?
Yes sir.
L common 1 minus cos theta. Okay.
Yes sir.
So whenever you see there is change in position of the string, height change, you can now remember this formula. Suppose they said 2 height. This is one angle theta 1 and this is another angle theta 2. So first will be 1 minus cos theta 1, next will be 1 minus cos theta 2, then difference of these two.
Yes sir.
Next part. A ball of mass 5 kg is dropped vertically. A ball of mass 5 kg is dropped vertically through a height of 20 meter and it gains speed of 10 meter per second after 10 meter. Find work done by gravitational force and air friction. Question write down, then I'm explaining it. Work done by gravitational force and air friction. सिंपल याद रखना, सब फोर्स का वजह से वर्क डन इज चेंज इन काइनेटिक एनर्जी. Just write the question, then I'm clearing this to explain you by diagram.
Done, sir.
A body of mass 5 kg is dropped, so initial velocity is 0 from the height of 20 meter total. Velocity, it gains speed of 10 after 20 meter. Okay, after 20 meter it is gaining speed. मतलब ये फाइनल स्पीड हो गया इसका 20 मीटर पर सेकंड. Sorry, 10 meter per second. A ball of mass 5 kg, m is 5, is dropped from the height of 20 meter. Its velocity is 10. After 20 meter, what is work done by gravitational and air friction? Now, work done by gravity is Fs. See, against gravity नहीं है, work done by gravity. तो इसका मतलब m into g into displacement मतलब 1000 जूल हो गया. Now work done by gravity and air friction total is change in kinetic energy. This is 1000. Friction wala we want. This is half m v final square minus v initial square. So 1000 plus v of air friction is half into 5 into velocity acquired is 10 square, 100, that is 0. So we'll get 1000 plus velocity acquired by friction is half into 5 into 100, 2 into 50. Therefore, friction will become 5 into 250 minus this. So we are getting minus 750. 250 minus 1000 minus 250. Followed? Hello?
Yes, sir.
Work done by gravity easily you can find, but total work done is change in kinetic. Just subtract.
Done, sir.
Okay. Now, Aryan, as per you said that dot product also we can use. See this one, next sum. A force F is 2i cap plus 3j cap acts on a body to displace it from 1, 2 to 4, 1. If initial velocity of body is 2 meter per second and mass is 10 kg, find final velocity. Can you try this?
Yes, sir.
Just take 1 minute, try. I think you will get correct answer. Done?
Yes, sir.
What answer you all got?
Sir, I got root 23 by 5.
Perfect.
Same, sir.
Perfect. Perfect. Root 23 upon 5. Perfect. So understood till this, whatever we have done? Conservative force, non-conservative force, work energy theorem related sums.
Yes, sir.
So that's all for today. Tomorrow again we'll meet. And regular students, those who have joined bit late, please complete till 100. And then 1 to 25 work power energy. RN I'm including in the group. In that group, will resend this work power energy Varashi. Okay?
Okay, sir.
Yeah. 1 to 25 and 1 to 100 from law of motion. Those who have done,
Law
they
of
need
motion, I've done 135 blocks.
155. Then try till 175.
Okay, sir.
But minimum 100 it should be done so that I can discuss first that. So tomorrow first I will discuss 1 to 25, 1 to 100 if there is any doubt, and then start with new topic, potential energy.
Okay, sir.
So that's all for today. Tomorrow same timing. Yes, Aslisha, any doubt?
No,
Are you?
sir.
No doubt.
No, sir.
Ananya, any doubt?